Bismillah ar-Rahman ar-Rahim. We'll continue this 5.2. I did also some one video for the sigma notation, which is very important to deal with, which is just mainly these formulas on how to deal with the sigma notation in general. So I did that. Now I'm back to this 5.2. We did all of this before. Mainly we have this. This is mainly what we have, where I have Rn and Ln, which is either I use the right endpoint or the left endpoint. Or yeah. Yes, or the midpoint. Also, we'll do some problems with the midpoint, and I have delta x is b minus a over n. I have a fixed width. In 5.3, we'll deal with non-fixed width, and xi is this. Xi minus 1 will be what? A plus I minus 1 delta x. Xi bar, you have it here, so you can do everything. Okay, so let us do some problems. So sometimes you ask you to find the area. To find the area, according to this, I need to find not only these Rn or Ln or Mn. No, I need also to find the limit. And that will give me the exact area, where we'll convert it to integral in the next section. Okay, so usually to do this, I think it's always good to start with the right endpoint, since it's since it will give us the easy calculation comparable to this one. I don't need to go to I minus 1 delta x, where they'll make the things, the I term in the summation a little bit complicated. So it's usually it's easy to deal with I, with the right endpoint. Okay. So I have the function. I have A. I have B. Okay. So I have delta x is B minus A over n, and that will be 1 over n. Okay. And I have xi is A plus I delta x. A is 0, I delta x, which is I over n. F of xi will be I over n all cubed, which is I cubed over n cubed. Okay. What will be the area? Very clear. It will be the limit of this sum. The sum is the product of f of xi times delta x. So let me do f of xi times delta x with the summation, and then I will take the limit. So I need to find summation I equal 1 to n, f of xi times delta x. Okay, that will be summation I equal 1 to n of what? I cubed over n to n cubed times 1 over n, which is what? So we'll do it like this, which is equal to summation I equal 1 to n. I have no need for that. I have 1 over n to the power 4. I can take it outside since it's not related to I. I equal 1 to n of I cubed. Don't forget the formulas, huh? This is the formulas. I cubed is this one. Plug it there. Oops. Going the other way. That will be what? Some 1 over n to the power 4 times n plus 1 over 2 square, which will give me what? This one is n square times n square plus 2n plus 1 over 4 n to the power 4, which is n to the power 4 plus 2n cubed plus n square over 4 n to the power 4. Okay. So what will be the area? It will be the limit, as in goes to infinity, of this. And that will be limit n goes to infinity. This one which I did, I'm doing it in detail since it's the first one to do. Now I have same degree, and we know how to do this, just the coefficient, so it's 1/4. That will be the area. Okay. Yeah. Yeah, you can do the same with the left endpoint. But the calculation will be a little bit more complicated. That's the only change. Nothing else to worry about. If you want me to do, I can do the, yeah, since I'm doing it, also I left a space for it. No, this is not the space, okay. Yeah, so I think that's, yeah, we'll do other problems. Left endpoints, the difference only you need xi minus 1, which is I think I will not do it here, plus delta x, which is I minus 1 over n. So when it comes to f of xi minus 1, it's a little bit complicated. I minus 1 over n cubed, where you need to open this and do the summation, which will make it a little bit complicated. I will leave it for you. But you should get at the end with the limit, you should get the same answer. Okay. Yeah, let me move to the next one. Let A be the area of the region that lies under this, between this. Using right endpoint, find an expression. He doesn't want you to find the limit as a limit, huh? He doesn't want you to find the limit. Find an expression for A as a limit. Okay, so same idea. I have delta x. This is A. This is B. And this is f of x. This is what you need. And I need the right end. Delta x will be what? B minus A over n, which is 2 over n. Xi will be A plus I delta x. A is 0. So that will be 2I over n. Okay. F of xi will be e to the power minus xi, which is e to the power minus 2I over n. The area, or before the area, or let me do it right away. Limit n goes to infinity, summation I equal 1 to n, f of xi delta x. That will be what? Limit n goes to infinity, summation I equal 1 to n. F of xy is at what? E is minus 2I over n. Delta x, what is it? 2 over n. Which is, that will be limit n goes to infinity, 2 over n, summation I equal 1 to n, e to the power minus 2I over n. That's it. This is not related to I, so I can take it out. No, this is one related to I cannot take it outside the sum. So that will be my answer. As a limit, this is the area. Can you do this? No, I don't have formulas to do that. So you cannot do it. Okay, find the area of the region bounded by the graph of this function, the x-axis and the vertical lines as shown in figure this. Okay. As I said, you can do the either right endpoint or left endpoint. Let me do it as usual. Usually the right endpoint, it will be easier since you have I only. That will be b minus a over n, so that will be 1 over n. 2 minus 1, which is 1 over n. Xi will be a plus I delta x. That will be what? 1, huh? Since a is 1, plus I over n. F of xi will be what? 4 minus 1 plus I over n square. Now I need to open this. 4 minus 1 plus 2I over n plus I square over n square. Okay. That give me what? 3 minus 2I over n minus I square over N square. Okay, the summation I equal 1 to N f of xi delta x. That will be summation I equal 1 to N. F of xi, it will be this times delta x, which is 1 over N. Okay. That will be what? Summation I equal 1 to N of 3 over N. Okay. Minus, let me do it in steps. I equal 1 to N 2I over N square minus summation I equal 1 to N I square over N cubed. That give me what? The first one, I can take 1 over N outside, and the remaining is summation y to N of 3 minus 1 over N square minus 2 over N square over I, summation of I, minus 1 over N cubed over summation I square. Oh, okay, plug the numbers now. That will be what? 1 over N times, this is what? 3N. Okay. Yeah. Because summation of 3, actually you can take it like this, make it 1, and this is 3 over N. What's the summation of 1? It will be N. Yeah, it will be the same. Minus 2 over N square. Now I have this summation, N plus 1 over 2. Minus 1 over N cubed. N plus 1 to N plus 1 over 6. Okay. The area, the area will be the limit of this, the limit of all of this, the limit of 3 minus N plus 1 over N square minus N plus 1 to N plus 1 over 6 N cubed. I can distribute the limit. You get what? 3 to the same degree, 1 over 1, which is 1. Here I have what? What is the highest coefficient? It will be 2n times n times n, 2n cubed over 6n cubed. This is what I need. The highest leading coefficient, or the leading coefficient in the numerator or the denominator, which is minus 2 over 6. That will be what? 2 minus 1 over 3, which is 5 over 3, which is the same answer. That will be the area. Okay. Find the area. Now I'll do it in the y side, huh? It goes the other way. It goes to the y values. The same thing, huh? Instead of fxy, I will deal with f of y. Okay. So I have delta y. That will be b minus a over n. My b is 1, since this is the y values, huh? 1 minus 0 over n, that will be 1 over n. xi will be a, yi it will be. That will be a plus I delta y. A is 0, it's I over n. Okay. That one was in the y and the x value. Now this is about the y value. Okay. So the area, or first I'll do the f of x, f of yi. That will be I square over n square. Okay. The area, limit, it goes to infinity, summation, f of yi delta y. I'm dealing in the y side, huh? Since I'm doing the summation like this, the approximation. Okay. F of yi, it will be summation I square over n square times delta y, which is 1 over n. So that give me what? Yeah. One limit, it goes to infinity, 1 over n cubed with the summation y lambda I equal to n I square. And that will be limit n goes to infinity. What is that limit? You have 1 over n cubed. And this is the formula, n plus 1 to n plus 1 over 6. Think about this limit. What is the highest coefficient here? Is 2, the leading coefficient. The leading coefficient is 6 in the denominator. So the answer is 1 over 3, which is just the correct answer. Okay, now I need to use the midpoint to find that. I'm not doing now the left or right. I'm doing the midpoints. I need to do this formula. Okay, but he want me to do it for a specific number of rectangles. Okay, so let us do it. I have the region between 0 and pi. That's my region. So delta x will be b minus a over n. So this is a, and this is b. That will be pi over n. Okay. My n is 4 over n. Yeah, so that will be pi over 4. That's the width of each rectangle, pi over 4, pi over 4, pi over 4. So if you want to do it between 0 and pi, to see it, I have pi over 4, I have pi over 2, and I have 3 pi over 4. Since this is pi over 4, pi over 4, pi over 4. Okay. Now I need to choose the xi. And after we split it, finding delta x, I need to find the xi bar, which is half xi minus 1 plus xi. Okay. So in the first rectangle, since it's the first time we are doing it for midpoint, so the first rectangle, think about this first rectangle, this is x0, first rectangle. Huh? I'm doing it in details. First rectangle. I have x0 is 0, and x1 is pi over 4. I need what? X. Usually they're using 0 or 1. Starting with 1, I have x1 bar is half of the sum of these two. So I have x1 bar is x0 plus x1 over 2. And that will be what? Pi over 8. Okay. Yeah, now the idea is very clear. x2 bar will be x1 plus x2 over 2. That will be x0, that will be x1, that will be x2, that will be x3, that will be x4. I think the idea is very clear. Now x1 plus x2, that will be what? Pi over 4. Wait a minute. Pi over 4 plus pi over 2 over 2. That will be what? 3 pi over 4. Huh? This is 2 pi over 4 plus, so that will be 3 pi over 8. x3 bar, it will be x2 plus x3 over 2. I'm doing it in details, and this is the first time we're doing it. Pi over 2 plus 3 pi over 4 over 2. This is 2 pi over 4. This one is 2 pi over 4. Pi over 2 is 2 pi over 4. So it's 5 pi over 4 over 2. So that's going to be 5 pi over 8. x4 bar will be what? Yeah. x4 bar, that will be x3 plus x4 over 2. And that will be what? 3 pi over 4 plus pi over 2. That will be 7 pi over 8. Yeah. Now, f of x1 bar, that will be sine pi over 8. F of x2 bar, that will be sine 3 pi over 8. F of x3 bar, that will be sine 5 pi over 8. F of x4 bar, that will be sine 7 pi over 8. Now, the approximation of the area, since I'm using only 4 rectangles, will be the summation I equal 1 to n f of xi bar delta x. That will be what? Since delta x is the same, so it will be pi over 4 times this summation. Sine of pi over 8 plus sine 3 pi over 8 plus sine 5 pi over 8, which is this one is f of x1 bar, huh? This is f of x2 bar. This one is f of x3 bar plus sine 7 pi over 8, which is f of x4 bar. Do the calculations. Either I think you need the calculator. That would be this, which is this value. But the idea is very clear, I think. Yeah, this first rectangle, I did it in details. The second class, this is first rectangle. This is second rectangle. This is third rectangle. This is the fourth rectangle. I need the point in the middle. That's the midpoint formula. Okay. Yeah. Let me go to more problems. Now, this is all the exams problems. Those was all the examples from there and there. Okay. Now I'm doing the all the exam problems. See what will happen. Okay. In that one, you need the calculator somehow. How to find sine pi over 8. Yeah, it's not an easy one. But in this one, no need. You'll see the angles will be nicer. Okay, I need to find 4 approximating rectangles and left endpoint, not right, left endpoint. Okay. 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 Now I need to find delta x as usual. That will be b minus a over n. I have n4. This is a. This is b. So that will be what? 2 pi minus 0 over 4. And that give me pi over 2. So the length of each rectangle, pi over 2. Okay. So I have 0 up to 2 pi. Pi over 2. Pi over 2. That's pi. Add pi over 2. That's 3 pi over 2. So I have now the 4 rectangles. 1, 2, 3, 4. Okay. Now I will do the right endpoint. I have delta x. I need the left. Oh, he wants the left endpoint. Left endpoint. Left endpoint. In the first rectangle, what is the left endpoint? Will be 0. It will be 0 here. I have xi minus 1, which is x0. That will be 0. First one, when I equal 1. First rectangle. When I equal 2, xi minus 1 will be x1, which is pi over 2. I equal 3, xi minus 1 will be x2, which is pi. When I equal 4, xi minus 1 will be x3, which is 3 pi over 2. Okay, now I need to find the approximation of the area. The approximation here, yes. This should be approximation, isn't it the area itself? Okay, that will be summation I equal 1 to 4 f of xi minus delta x. Okay, so that will be what? Delta x is the same, pi over 2. I can take it outside, which is very clear here. times. I have f of x0. When I equal 1, I have f of x0 plus f of x1 plus f of x2 plus f of x3. Okay, that will be pi over 2 times what? F of x0 to be f of 0, which is sine 0 over 2. Plus x1 is pi over 2. x1 is pi over 2. So I have sine pi over 2 over 2. Okay, I'm doing it in details. Plus sine x2 here by sine pi over 2. The last one, sine 3 pi over 2. 3 pi over 4. Let me do it like this. 3 pi over 2 over 2. That give me what? Pi over 2. This is sine 0, which is 0. This is sine pi over 4. That would be sine over 4 square root 2 over 2. Okay. Sine pi over 2, that is 1. Sine 3 pi over 4, second quadrant, is still square root 2 over 2. So I have pi over 2 times 1, this plus this, give me plus the square root of 2, which is this one. That's the answer. I'm going slowly, just to be sure, we get the idea. Because there is, usually there is a question related to that. Now he wants to deal with the len and with the exponential so that you can do the calculation. He put the intervals with the len things. Okay, I need 4 rectangles, left endpoints. Under this curve, this is f of x, and this is a and b. So I have n equal 4, a 0, b, then 16. Okay, so it will be my delta x would be b minus a over n, and that will be 4 minus 0. No. That will be len 16 minus 0 over 4. Which is what? If you notice, that will be 1 over 4 len 16, which is len 16 to the power 1 over 4, which is len 2. Okay, so that will be delta x. Now I need the left end points. Okay, so the intervals will be what? 0. I need to reach len 16. The length is len 2. I add len 2. So this will be 2 len 2, which is what? Len 4, Okay. This one will be 3 len 2, which is len 8. And that one is 4 len 2. You add len 2 every time. So the length is len 2, len 2, len 2, len 2. So these are my points. So first rectangle, what will be? I need what? Yeah, the area will be approximately summation I equal 1 to 4 f of xi minus 1 delta x. Okay. So now this is what? Delta x, which is len 2, len 2 times f of x0 plus f of x1 plus f of x2 plus f of x3. By the way, this is x0, this is x1, this is x2, this is x3, this is x4. I don't need x4 since I'm doing left end point. So in this rectangle, I'll take x0. So that will be len 2. F of x0, this is my function. So it will be e to x0, which is 0. Then I have e of x1, which is len 2. Which is len 2. Len 2. Here I have, this is f of x1. Now f of x2, I have plus len 4, e to the power len 4, plus e to the more ln 8. That give me what? Ln 2 times what? A to the power 0, 1, plus 2, plus 4, plus 8. And that will be 15 ln 2, which is this one. Okay. Use 3 rectangles and midpoints. In this case, he wants the midpoints, and this is the function. He wanted to do the calculation. Okay. The same idea. I have delta x, 3 minus 0 over 3. That will be 1. So my rectangle 0, 1, 2, 3. Those are my rectangles, each one of length 1. So what is the midpoint here? x1 bar, that will be half. Here, x2 bar, 3 over 2. Here, x3 bar, that will be 5 over 2. I think this will be easier. So my area approximation will be summation I equal 1 to 3 f xi bar, which is usually they use it for the mid, times delta x. Delta x is 1, so we just ignore it. So that will be f of x1 bar plus f of x2 bar plus f of x3 bar. F of x1 bar, which is f of half. So I have half over half plus 1. F of x2 bar, I have 3 over 2 over 3 over 2 plus 1. This one, 5 over 2 over 5 over 2 plus 1. Let us do the calculation. That will be half over 3 over 2, which is 1 over 3, plus 3 over 2. I'm doing it in details. Plus 5 over 2, plus 5 over 2 over 7 over 2. That will be 1 over 3, plus 3 over 5, plus 5 over 7. Yeah. Now, what will be the common denominator? I have 3 times 5, which is 35 times 7. 35 times 7. 5, 3. Okay. 35, not 35, 15 times 7, 53, 105. So that will be 105. You divide by 3, then I have 5 times 7, that will be 35. Here I have 21 times 2 times 3. Here I have 5 times 15. Okay, I just divide by this, multiply by this. That will be what? 35. That's 63. And that is what? 5 times 5. Yeah, 75 over 105. That will be what? 35 plus 75, that is 110. So I have 173 over 105, which is this. Yeah, it's a matter of calculation. Not difficult. It's a matter of calculation. Using theoretic approximation and using left endpoints, the area under the graph of this, yeah, the same idea. We are repeating it. So it's just a matter of calculation. And since I'm using fixed width, so I have starting from 0. Yeah, what will be delta x? P minus a over n, which is 3 minus 0 over 3, which is 1. Huh? So the same idea. 0, 1, 2, 3. I'm using the left. Huh? So I'm using this, this, this. Okay, so that's the area approximately. The summation I equal 1 to 3. F of xi minus 1 delta x. Delta x is 1, so we just ignore it. That will be f of x0 plus f of x1 plus f of x2. That will be f of x0. It will be 1. F of x1, 1 over 2. Huh? F of x2, 1 over 9. So that will be 18. I have 18 plus 9 plus 2, which is what? 11 plus 18, 29 over 18, which is this. I think it's easy. The rectangles and midpoints. Here I have midpoints. Okay. They have delta x will be 7 minus 1 over 3. I think that's usual. B minus a over n. That's 7 minus 1 over 3. That will be 2. So I'm starting with 1, then I go to 2. I add 2, so that will be 3. I add 2, that will be 5. I add 2, that will be 7. So what is the mid here? X1 bar will be 2. X2 bar will be 4. X3 bar will be 6. So my area approximately summation I equal 1 to 3 f of xi bar to represent the midpoint times delta x. Delta x is 2, so I can take 2 outside. The remaining is f of x1 bar plus f of x2 bar plus f of x3 bar. That will be 2. F of x1 bar, it means f of 2. F of 2, f of 2. F of 2 is 2 minus half. F of 4, 4 minus 1 over 4. F of 6 will be what? F of 6. No, 2. This is 2. This is fixed 2. 2 minus 1 over 4. 6, that will be 2 minus 1 over 6. Okay? So it will be my answer 2 times 2, 2, 2, that will be 6. Minus 1 over 4 minus half, minus 1 over, that will be minus 3 over 4. Minus 1 over 6. That will be 2. 6 minus. I'll do a common factor. That will be 12. Okay. 12 over 4 is 3 times 3. That will be 9. Over 6, that will be 2 plus 2. Yeah, since this is a minus, it will be like this. Huh? So I'm taking minus as a common factor. That give me what? That give me 12 minus 11 over 6. Okay. Yeah, that will be 11 over 12 times 2. That will be 11 over 6. So that give me over 6. 6 times 12, that will be 72 minus 11, which is 61 over 6, which is this. Okay. I'll do more problems. The same idea, it's going back and forth, huh? Okay. Using 4 rectangles, take the sample to be right in point. I need 4 rectangles, n equal 4. This is A, this is B, this is A, and this is B. I need 4 rectangles. Okay, so what will be delta x? B minus A over N will be 1 minus 1 over 4. That will be 2 over 4, which is half. So my rectangles, I starting with minus 1, I add half. That will be minus half. I add half. That will be 0. I add half. That will be half. So I have 1, 2, 3, and that will be the last one. I add half, it will be 1. Okay, so this is my starting point, and this is my end point. Also, I need to do right endpoints. So I will choose minus half, then 0, then half, then 1. Okay. The area approximately will be the summation. I equal 1 to 4. F of xi delta x. Delta x is what? Half. Okay. So that will be half f of x1 plus f of x2 plus f of x3 plus f of x4. That will be half times what? F of x1 is minus half. That will be 2 minus 1 over 4 plus f of x2. F of x2, this is x1, huh? This is x2, this is x3, this is x4. Huh? Okay, f of x2, that will be 2. 2 minus 0, which is خلاص 0. Let me make it 2 minus 0. Plus 2 minus. 2 minus what? Half square, which is 1 over 4. 1 over 4. Plus 2 minus 1. Okay, that will be half. This is 2, 2, 2, 8. This is minus half. So I have 2 plus 2, 4 plus 2, 6 plus 2, 8. So to have 7 minus half. In other words, it will be half. 14 minus 1, 13 over 2. And that give me 13 over 4. That give me 13 over 4. Okay. 4 rectangles and left endpoint. This is the function from 0 to pi. I think we did this before. Yeah. Somehow we did it. No, it's a different one. Okay. The same idea, but okay, let me do it since I want to do all of these problems. I need 4, n equal 4. This is A, this is B. So I have delta x is B minus A over n. That will be pi over 4. So I have what? You have 0. Then add pi over 4. That will be pi over 4. Add another pi over 4. That is pi over 2. Add another pi over 4. 3 pi over 4. The last one should be pi, which is the last point, which is B. خلاص. So I need the left endpoint. So I need these points. So my area approximately summation I equal 1 to 4 f of xi minus 1 delta x. That will be pi over 4, which is delta x, times f of x0 plus f of x1 plus f of x2 plus f of x3. Okay, that will be pi over 4 times what? F of x0 sine 0. Let me write it, sine 0. F of x1 sine pi over 4. Then I will do the calculation. Plus sine pi over 2 plus sine 3 pi over 4. Okay, that will be what? Sine 0 is 0. Sine pi over 4 square root 2 over 2. This is 1 square root 2 over 2. So that will be pi over 4, 1 plus square root of 2, which is this one. Okay. 4 rectangles. Yeah, I will do these 2, then I will stop. Using 4 rectangles, take the sample points to be left endpoint. Left, n equal 4. And these are samples, minus 1 to 1. I did this. Or I did something similar. Minus 1 to 1. Where is minus 1 to 1? Yeah. It's 2 minus x squared, not 1 minus. Okay. Different a little bit. Let me do it. Delta x will be b minus a over n. That will be 1 minus minus 1 over 4. That will be half. So I have minus 1. Add half, that will be minus half. Add half, that will be 0. Add half, that will be half. Add half, that will be 1. So I need what left endpoint? So I need these points. So my area approximately summation I equal 1 to 4 f of xi minus 1 delta x. That will be delta x, which is half times f of x0 plus f of x1 plus f of x2 plus f of x3. Yeah, I'm doing it in details. Hopefully it's now the idea will be very clear to everyone. With minus 1, I have 1 minus 1. Let me do it in details. Plus 1 minus 1 over 4 plus 1 minus 0 plus 1 minus 1 over 4 again. So that will be half times what? This is 0. Half 1 plus 1 plus 1. That will be 3 minus half, which is what? 6, 5 over 2. So I have half times 5 over 2, which is 5 over 4, which is this one. Okay. Using theory of midpoint. You want the midpoints here. 1 to 7. What will be delta x? Here's 3. N equal 3. It will be b minus a over n. That will be 7 minus 1 over 3. And that is 2. So I have 1, add 2, that's 3, add 2, that is 5, add 2, that's 7. I need the x1 bar, which is 2, x2 bar, which is 4, x3 bar, which is 6. So my area approximately will be summation I equal 1 to 3 f of xi bar delta x. Delta x is fixed is 2, take it out. So I have f of x1 bar plus f of x2 bar plus f of x3 bar. That will be 2. F of x1 bar, just substitute the 2 here. I have 3 over 2. F of x2 bar, 4 substituted there, so I have 5 over 4. F of x3 bar, I have 6, so 7 over 6. That will be 2. What is this? Yeah, method of calculation. I take 12 as a common factor. Divide by 6, that will be 18. 3 plus 15 plus 2 plus 14. That give me what? Yeah, 14 plus 18, 32. 32, that's 47. 2 times 47 over 12. And that will be 47 over 6, which is this one. Yeah, I think we did, many problems. We want every video to be short. Not that, almost 40 to 45 minutes, 50 minutes. So I think I'll stop here the recording for this one. Thank you.